All right. Hello, welcome, and thank you very much for your interest in this topic. My name is Francis Andolfo. I come from Heidelberg University, Germany, and I am a PhD student there who is basically looking at data quality as my topic. So today I present to you what we call transparency and trust in collaborative mapping, to highlight some of the concerns and then also talk about the facts and the dilemmas that is within the OSM community at the moment. And I'd like to start with the exercise. How many of us believe that the green road is actually coming from humans? How many believe that it's coming from AI? How many believe that the red line is coming from human? How many believe that it's coming from AI? Okay, so we have more hands saying that the red line is coming from AI. I'm not going to ask you to tell me why, but I'm going to assume that likely you are making this decision because of the rough edges that we see there. So by default, everyone has this assumption that AI, the quality of AI is wrong when it comes to bringing humans and AI together. And without data and facts, we would always assume, and we have seen vandalism that probably look worse than this or probably the same as this. So humans are also capable of doing something like this. And the second exercise I want us to do is, how much of this data do you think it's coming from, or how much of it comes from AI? Can you tell? Yeah, but this is really difficult. Just by looking at the data, it's difficult for you to give any value and say that this is coming from AI, this is how much comes from AI or not. What if you download the data and you get information like this? Would it be helpful for you? But now we cannot do this. And this is what I want to highlight in this presentation. The baseline that we got from when this whole AI started, we first got data from Meta and then Microsoft. And when they gave us the data, after that, I think they stopped giving it and now they take it through the rapid editor. But then we use the first data we got as a baseline. And this is the data that we got, let's say, for lease, but that is the attribute. There's nothing that we have about it. And just by looking at the data, when it mixed with OSM, then we are not able to tell again where the data comes from. But what human in the loop did, or what AI-assisted mapping did, is it picked this, place the human in the middle, assuming that the human will check every data that comes and then provide some extra information. So at the end of the day, we get something like this. It makes it very useful. But the human has a lot of options when he is in the loop. Now, the difference between what we have here and then what we have there is the human judgment. Assuming that the human thought something was wrong. He may have changed the data, he may have added something to the data, or he may have even deleted the entire data. We don't know what the human does. But the human can recreate, like I said, he can delete nodes, he can split the data, he can extend, he can merge, and he can do so many other things. The challenge is that at the moment, the popular tools that we use for AI-assisted mapping are the rapid and then the plugin in GeoAI. If you look at it, in GeoAI, we always have a tag that says hashtag map with AI and then hashtag the country. However, if we come to rapid, it's always hashtag the project name, hashtag the country. What this means is that we are supposed to know the project ahead of time to be able to make a filter if you want to filter for the data within the OSM. Once you mix them together and we want to separate them to be able to check the quality of both, we'd have to do this. But we check the wiki and try to get this information, but we are always unsure how much do we know and how much can we capture with the limited information we have. So we came up with a research question, and that was, can we detect, or can we reliably detect the roads, or can we reliably detect the data, whether it's coming from AI or human, just by looking at the geometry of it as a way around to the fact that there is no explicit metadata for us to use, because the only thing they gave us is geometry. So we wanted to rely on this geometry. Can we do this at all? And we did this by looking at two points. So we did two studies in one. The first study is to look at what do the OSM community feel about this whole AI going into the OSM database. And then also answer our question based on what they feel. The reason why we did the first one was to be able to validate our point. So this is an accepted paper which has been published. It's more pages than what I'll present here. So we needed to provide a reason why this question was even important anyways to look at it. So we had to be able to do this. So we took data from the discussions that was going on in the OSM forum. We took 3 different discussions. One discussion was basically trying to say that we use AI to provide tagging assistance for mappers. The other one was also someone who developed a plugin for, I think, Mozilla, which allows you to be able to map swimming pools and stuff within OSM. And it became a discussion on the forum where people were expressing what they like and what they don't like about it. And then we look at the third one, which was a claim that there is about zillions of buildings that has been imported into OSM. And so it became a long argument. I'm sure those of you who are really present on the forum, these are very popular to you. So we picked this, and then we took the thread of the conversation. So we extracted all the thread of the conversations, and then we had the summary. So issues regarding tagging was 42 unique comments, and then issues with editors using the AI content in the editor also was 58, and then using the computer vision, that is a plugin in Mozilla as an example, was 37. And so we did a natural language processing on it, and basically what we did was we just wanted to do a sentiment analysis. So we looked at the sentiment of the people, comments that came from the thread, and this is the result. Obviously, many of the people had a negative comment about this whole inclusion of AI. And if you want to get to know, I think we came up with 5 big umbrellas of what the comments summarize to. So if you want to know what those comments are, I'll be happy to share the paper with you once it's published, and then you can get to know. But then we try to answer our second question, which is, can we use only the geometry to be able to detect, since we cannot rely on the attribute? And we had this hypothesis. Our hypothesis was that algorithms are obedient, they follow rules and laws, whilst humans are not. And so there is a likelihood that the algorithms are going to provide consistency in the distance it places in between the nodes and the number of nodes it used to create, let's say, 1 kilometer. If you give 10 humans the task to create 1 kilometer stretch, each of them will use different nodes, different number of nodes and different distances between them. That's what makes them human, because everyone has different preferences. Some want to map more detail, whilst others want to map just a shallow information. So we looked at 2 indicators, which was the node density, the number of nodes that are used to construct a particular length segment of a road. And then we used the standard deviation of the node distance. Standard deviation, because this was a bit easier and convenient for us, but if you want, this is a way to summarize the distances, many distances we found in the paper. Then we had to test this, so we tested this with 2 different statistical tests. And the first test, we tried the node distance, or our hypothesis was basically saying that the spacing differs between these 2 groups, AI-assisted group and then the pure humans. And so we used the t-test to test this. And then also we used the KS to be able to test for whether the underlying distribution, which is the node distances, whether the underlying distributions are the same or not. And the assumption by default, the null hypothesis was that the 2 of them were supposed to be the same. After testing for this, we got the results. So t-test, which basically ranges from negative infinity to positive infinity. The further you go in negative means that they are not, and then the higher you go in the positive means that they are. We got a negative 968.118, which is way far from zero, so telling us that in terms of the number of nodes the humans and the AI uses to construct a road segment, they are not the same, and they are not supposed to look alike. We did the same with the KS, and the KS also gave us, it ranges between 0 and 1, where 1 is, the more you get closer to 0, it means similarity. The more you move away from 0, it means that they are not similar. And so by the distribution, they are also not similar at all. So statistically, this tells us that we should be able to tell if this data comes from AI or not, just by looking at the geometry. But this is not the case. So when we looked at our hypothesis, we tried to look at what's the reason. So visualizing it, you realize that the humans actually use short distances for their road constructions, while the AI can use very long distances for their road construction. The humans also use little or few nodes to construct, whilst the AI use too many nodes to construct a segment. And so we kind of realize this, but there's some sort of overlap we have seen in the data, which I'll try and explain this. But going into our methodology, what we did was that we took the first, I think 2019, 2017, Facebook gave, and Microsoft also gave 2020, the data from AI. So we had that raw data from GitHub. We took that one as our benchmark, which is how the data should be. And then we went into the OSM. So OSM database had already been mixed up. So what we did was that we looked at the timeline. We started getting this data from 2017 openly. And so we said that all data that's as from 2015 backward as human. We used the 2 years buffer because we were not sure whether when we saw in the public is when actually started, or there was actually some things going on behind the scene. So the 2-year buffer was supposed to help clean this uncertainty that we had. And then we looked at using the hashtag. So we use hashtag like hashtag map with AI, hashtag rapid. We look at the rapid editor. This is using the chain set. So we look at the data set that was created using the rapid editor. We also looked at the import catalog to be able to see whether there has been some import in there. And we looked at this. We did the diagnosis in Malaysia, and then we tested it in Tanzania. And this was because these two countries were the first countries that Meta started doing piloting when this whole AI-assisted mapping came up. So we knew that they had more data for us to use. Now, we build models, but our models was not to build a model and say we have detected AI, because from our exploration, we got to know that it wasn't possible. And it was because we came to realize that the overlap between them creates a lot of confusion, that we are not able to have a high accuracy enough to say that this is coming from AI, this is not coming from AI. Rather, we wanted to use the model as a diagnostic tool to find out what is possible and to what extent is that possibility. And so we did a rule-based, which is from our knowledge, from learning and playing with the data, we understood the data. So we split the data into bins according to their node density. We did the natural breaks, using the natural breaks. We split them into 5 bins. And we tried to get a threshold for each of the individual bins. So each individual bins had different threshold that used to separate the data. And then we looked at putting all the data together and ran logistic regression and then XGBoost and then random forest on it. But you can see that the rule-based performed better than the sophisticated machine learning models that we know. And then generally, the benchmark, which is the raw data that comes from Meta and Facebook. So what did that? We mix this together. The raw data that comes from Meta and Facebook is generally, it's also performed better than the one that we get from OSM direct. And so we try to look at we visualized the rule base because that was really performing. The reason why the rule base was performing is because if you look at the data, in bin 1, there's a very big overlap, and in bin 5, there's also a very big overlap. But if you look at bin 2, 3, and 4, there's a separation. There's a possibility to separate them. There are a lot of questions this raised for us when we were doing this research. We were asking ourselves why the overlap. Is it that the original, because statistically we have seen that they were supposed to be separated, but then in reality it's not. So is it that the humans did not touch it in the loop? They didn't touch the data at all, they just allow it to flow? Or it's because this is by chance? Our definition of road means that it should have a minimum of 2 nodes. And what that means is that even if you have this short road segment, even whether it is machine or human, for qualification, 2 nodes would always be there. And so there's likely by chance that 2 nodes were created by humans. So that could be a possibility. We don't know. We have not been able to rule that out. But the other thing is that why is there a clear separation between the 3 other bins? And it could also be that these 3 other bins was because that the original data was untouched. And we want to understand what this is happening, but we are kind of poor in terms of data availability. The data we have does not go beyond certain level, which I hope this presentation could give us an opportunity to discuss about it. But what we did is that we added time to it. If you add the month of the year to the model actually starts to perform better, even better than the benchmark. And we wanted to find out why is this so? So the month that we added, we tried to check the distribution of the data in terms of month. If you look at it in Malaysia, this is done in Malaysia. In Malaysia, for instance, the beginning of the year and towards the end of the year was where AI-assisted mapping was really going on. We don't know why, but our assumption is that this was a project, and so this project has times and dates that things were happening. And so this is likely to create this clear distinction for the machine learning algorithm to be able to clearly say, okay, this is coming from AI. But this is not sustainable because we realized that just after 2021, when the project ended in Malaysia, the number of data coming from Malaysia, the entire number of data that comes from #map-with-AI dropped drastically. Meaning when people were using it, they were using it because of a responsibility. It's a project, they were supposed to do something. They used it. When the project was over, they didn't use it. So we're saying it's not sustainable because the rollout of AI-assisted tools has not yet been accepted by all, and so it's not a daily tool that people are using. When we get to the level where people use it every day, month of the year might not be a good indicator to use. And so we don't rely on, and we are not encouraging that build a model with demand because it makes progress. So we look beyond this and try to look at what is the black box. Now, I've already shown this. We are wondering, the human could have done any of these, but now the research question that we wish to go further, we don't have, is what role does a human actually play in the loop? We know there is a human in the loop, but now we want to know what role it plays in the loop. This is possible. We can answer this question if we get the data of before and after. And so there's an AI data that is suggested to the human, and the human is supposed to do something to the data and push it. If we get the data that came from the human before, and we compare to what he did after, we can be able to tell what the human is actually doing in the loop. But Meta or any of the organizations don't release the before data. So we are not able to answer this question. And we are looking for a collaboration to see how we can work together on this, either close, for us to just give the answers to this question, whether on closed basis or on open basis. We'll be happy to be able to answer the question, what role does the human play in the loop? And now we cannot afford to answer this question, unfortunately, because we are poor in data, and we are looking towards this. Now, what we want for the future is that in the future, we are warning that there's likely to be what we call the data validation loop bias. That is, there's a model that is being built, and this model is built that it's going to be used to improve completeness. The assumption is that there is a human in the loop who is going to check the model anyways, And so there's a likely and a tendency that when you build a model and the quality is not that good, you would say that, don't worry, it won't go into OSM until a human looks at it, or a human will look at it anyways. We have also seen that there have been other projects that we probably can show you. We have also seen that sometimes the humans also feel they are not morally right to judge the output of an AI, so they accept everything that goes in. And so thinking that the human would do it, the human also thinks that the model has done it, would create this loop bias, and then we realize that the data quality would start eroding over time. We don't know whether this has started already, but we are only creating the awareness that this is likely risk that we are going to have if we are not able to clearly define what role is the human playing in the loop and be able to know where we put effort and resources in terms of, are we training more people on AI-assisted mapping, or are we actually looking at the other thing? So which brings me the second thing, which is the accountability sink. When something goes wrong, who do we blame? Do we blame the model or we blame the human? At the moment, it's very easy to blame the human, which is very convenient to do. But we actually don't know much what the human is doing in the loop. And so if we are able to tell exactly what the human is doing in the loop, and we have a problem, we know who is accountable for it. What do we need to do? Is it that we are improving the model, or is it that we are going to get more humans, or try to simplify the process? We have a lot of questions that we don't have answers to. And we'll be happy to provide answers to these if there will be data available, which we know it's available, but accessible, if there could be data accessible to us researchers to be able to do this. So I give you one example. During the 2023, just after the Syria earthquake, HOT published a blog trying to explain when they started using Rapid. So humans were supposed to be in the loop, and they realized that all the beginners were actually accepting there was a default residential road that was attached to the data that was presented to them. Even when it was obvious that it wasn't residential, all the beginners who were actually as part of the project were just accepting it. And so they had to stop and change the tool and start to use a different tool, because they realized that when you present it to the human, they just accepted it and let it go anyway. They don't feel like they are supposed to judge it or scrutinize what comes from the AI, which is something that is an already ongoing evidence of what we want about the validation loop bias thing, which is likely to happen a lot over in the next few years. So our take-home lesson is that the model performed better on benchmark scenario than change set. There will be a limitation in the way we did it, especially the 2015 timeline we provided could have created some artificial line that will make this difficult. But we couldn't think of any better way to do it, looking at the situation that we had. So we admit that our method could play a role, but we think we try as much as possible to be objective enough to provide this. Time could provide some information, but it's just a proxy for the rollout of AI-assisted mapping. When it's settled with people, time will no longer be a factor in this, as it's doing in the model now. And we say that models like this could only, if you try to build a model to do things like this, they could only work on freshly imported data from these tools, because other people can go and take the data and also add something to it. So the more it goes, the more complicated it becomes for you to tell the difference at all. So from scratch, if we target, we would be able to monitor the evolution of the data as human touches, or evolution of the data as time goes by. So the distinction between the AI and the human would continue to blur from our experience. We say that it's going to blur as the integration deepens. And so we need to provide a standardization in the tagging system that we have in the AI-assisted mapping at the moment. We do not have, and the absence of this tagging system or tagging framework is actually going to make the problem more serious than we have at the moment. So in conclusion, we asking for two things: prioritize AI-assisted mapping, tagging standardization. And then secondly, also make available the original data set. If there is a way to link them, the before and the after, if there's a need to collaborate to work on this to make this data available, it would be a good thing for us to have, so that we can be able to provide more answers with regards to AI-assisted mapping and quality. And once we have this, I don't think that it would be a problem whether people are using AI or not, because we can tell afterwards anyways, and we can separate them. And people who download can actually be provided with some transparency. This is the percentage that comes from AI, or that originally came from AI, and this was the one that was created from humans' own creativity and his local knowledge. This is the team, and thank you very much.
Got 3 minutes. Do you want to do questions?
Yeah, if there's a question, if not.
We've got 3 minutes. If anyone has got questions? I don't think there's a mic in here, so do you want to just put your hand up?
A bit of a comment, I suppose, regarding the data property. Perhaps it might be possible to think about if these commercial companies are not willing to provide the full data, maybe FAIR could be a collaborator that might provide before data and actually be able to analyze what the human is doing in the.
Yeah, I think it would be nice, but FAIR is not currently doing on roads, right?
No, not roads.
Yeah, this was done only on roads, and I wouldn't say that commercial companies are not willing. We have not asked them because we don't have access to them. So I was thinking this conference would be a way to meet some of them, and then we talk about it. Yes.
The question is about, relatively recently in a Mozilla translation project, the Japanese community essentially resigned because of the AI-assisted tool significantly overrided their work and was placed before human. And one of the points they brought up was having human, relegating human to just verifying AI output removes the ability to train new contributors. I was wondering if you and the team kind of looked into that direction, in that ethical and then organizational bit of it?
Yeah, so I took that slide out because it was controversial. So what we did was that we just have a criticism. We had the same criticism. We think that when you present humans with an output, there has been a lot of papers on automation. When you put human in the loop for automation, when you just intentionally create errors, the human will accept all the errors through the automation. They do not feel that they have the right to judge the machine output. And so when you put human in the loop and you relegate its responsibility to only validation, you have taken away creativity from them, because whatever they have to create, they have to continue from what you have given to them. And you have also limited them in terms of their creativity, because you have already given them ideas and they would do it in that line. We may be wrong, but we didn't do any evidence-based analysis in regards to this. Yeah, I don't know if I have time.
Yeah, maybe one more. Is this red line or the green line human? Beginning.
I think we should probably wrap up.
I think the red line was AI.
Okay.
Yeah.
I'm lead validator for HOT.
Okay.
In the Turkey, Syria, you're quite correct. That was a problem we came across. But what we saw in the divide was the beginners were more likely to just download the AI direct, and the more advanced mappers rejected the AI and found it quicker to draw it from scratch. So that's the split that we saw happening in Turkey, Syria. And after the third project, we stopped AI altogether and just got them to map straight.
Yeah.
Cool. I think
Thank
we should
you.
stop there. It's very fascinating. Thank you. It's a great talk. Thank you so much for answers.